Welcome to Global Virtual School. Students, this is your first year chemistry class. I am Dr. Jalbano. We are on chapter number 2, atomic structure, and the topic for today's discussion is X-rays. In X-rays, you will learn about its discovery, production, properties, and its applications. After completing this topic, you will know all the phenomena related to the X-rays. So I will just recall you about the properties of cathode rays in the discovery of the cathode rays, or you can say that was later related to the discovery of the electron. We have learned one property that when cathode rays strike on the anode of high atomic mass, then there are production of some radiations that were given the name X-rays. This is the example, like this is like discharge tube. It contains two electrodes. One is cathode of negative charge that is attached to the high voltage battery. One is anode of with positive charge attached to the high voltage battery. Vacuum pump and the gas inside it. And when the cathode rays are produced, if these cathode rays strike on the anode of heavy metal, then there is the production of some radiations that were given the name X-rays. And because X-rays produce in all the directions, so they are given a window to give the direction. So today we will discuss about these X-rays, its discovery, its properties, its relation with atomic number or atomic mass, and also its applications. Students, basically X-rays were accidentally discovered by Röntgen in 1895. He discovered that if cathode rays are pointed to fall on a heavy metal target, students, heavy metal target means anode of the metal having high atomic number or of high atomic mass, and there are production of some penetrating with short wavelength, then these rays he called the X-rays. And these X-rays are basically electromagnetic radiations of very high frequency. High frequency means high energy. High energy means low wavelength, shorter wavelength, and high frequency means higher wave number. And these are electromagnetic radiations. They travel in the space with the creating electromagnetic field, and like ultraviolet radiations are also electromagnetic radiation. Visible light or infrared, these all are electromagnetic radiations. And the frequency of these rays depends upon the nature of the anode, nature of the metal that is used as anode. If the it varies with the change of the metal, and usually for this purpose the anode used is made of tungsten. Tungsten is the metal represented by W. Tungsten filament is used for this purpose. And the X-rays are emitted from the target in all directions. In previous picture you have seen that X-rays are given a window, because X-rays are producing in all directions, and these X-rays are dangerous, so that's why for some useful purpose they are used from a window. They are given the window. And the X-rays are very related to the atomic number of the elements. This was understood by Moseley. Moseley in 1913 undertook a systematic and comprehensive study of X-ray. He studied in a regular manner and a deep understanding of the X-rays, and X-rays of different wavelength, like from 0.04 angstrom to 0.08 angstrom. 1 angstrom is 10 raised per minus 10 meter. So this is very short wavelength. So he studies in this range of the X-rays systematically and comprehensively, and he observed the some factors that frequency of the X-rays increases in a regular manner from one element to the other in the periodic table. Frequency increases in the periodic table from one element to the other element, and you know in the periodic table when we move from the left to right, their atomic number increases, their atomic mass increases, and the frequency also increases from one element to the other element in a regular manner. And he also observed that the frequency of these rays are directly proportional to the number of photons in the nucleus. So photons, I told you in previous lecture, photon are the wave packets of the energy, and in case of, this is quantum, in case of radiation of energy, this is called the photon. And so the photons are frequency of the photons are direct proportional to the atomic number. And in Moseley's law we will come to know what is exact relation. There is a direct relation of frequency and atomic number, and but how this will be understood with the help of Moseley's law. Moseley's conclusion was from 38 different elements, from aluminium to aurum. Aluminium is metal, and there are a lot of more metals, and aurum is also a gold metal, as target in the X-rays too. He used aurum, aluminium, aurum, chromium. I will show you the in product table. This one is aluminium metal, gallium, zinc, copper, nickel. These are pink color. These are the metals. These are poor metals, but these are metals, and these are transition metals in that pink block. So he used 38 metals as a target metal, target anode to observe the X-rays, and he observed that the spectral lines classified into two distinct groups. One spectral line of the X-rays with short wavelength are given the name K series, and the other spectral lines of the X-rays with the longer wavelength are given the name L series. If the target element is of higher atomic number, the wavelength of the X-rays becomes shorter, like this. You know, frequency is proportional to atomic number, and we know frequency is inverse proportional to wavelength. It means wavelength and atomic number is inverse proportional. This is saying if the target element is of high atomic number, high, if atomic number is high, the wavelength of X-rays wavelength will be less. So in this way you can say if the atomic number is higher, then wavelength is shorter. If the atomic number is higher, then frequency is higher. Hopefully it will be clear for you. And on the basis of this, he gave a relationship, an exact relationship between frequency and the atomic number. In this way, you can calculate the atomic number with the help of frequency. Relationship between frequency and atomic number of the element is given. This is the relationship. Frequency, the square root, equals to A into Z minus B. Z is the atomic number, A and B are constant. And the Moseley's law are defined as, this law states that the frequency of a spectral line in X-rays, in X-ray spectrum varies directly as the square of the atomic number of the element. If you take the square of on the both side, this square, if you take square, then square cancel with the square root and they got the square. And here you can see frequency and atomic number Z, and it had the square, and this is the Moseley's law. Frequency varies, changes directly as the square of the atomic number. So exact relation is frequency direct proportion to the square of the atomic number, and this is the Moseley's law. And with the help of this X-rays, atomic number and orbital structure, Moseley calculated the mass atomic number of elements with the help of these X-rays and their frequency. In 1930, Moseley used the technique X-ray spectroscopy. He used the techniques. This technique was discovered by Max von Leo. He just used his technique, Max von Leo's. To determine the atomic number of the elements, he used this apparatus and he changed this anode with different mass of the elements, and with the help of these X-rays he determined the atomic number of the elements by these steps. First, electron in the cathode rays hits the metal atom in the orbit. I'm just for your understanding, I'm giving you, this is the atom of a metal. Only this is one atom. It has different energy levels and in orbits, and this one is like its mass. So maybe electron here, maybe in this s or p or d orbital. Electron can be in any other energy level. Electron in the cathode rays. So cathode rays, and you know how the cathode rays are produced in the discharge tube experiment. Let's suppose these are the cathode rays. Cathode rays basically electrons. These are cathode rays. When they hit the electron of the metal atom, electron having sufficient energy can knock out the electron from an inner shell of the atom. If these cathode rays electrons have sufficient energy, they have the ability to knock out these electrons from here to out of the atom, like this. Okay, if there is sufficient energy, they can knock out this electron, so there remains an empty space here, this one. If these cathodes have sufficient energy, they have the ability to knock out this electron from the atom. Removing the electron is called knockout. So there is an empty space from where the electron is removed. What happens now? This is the metal ion. It's the ion, but this is unstable. Why? Because electron is removed from the inner shell, from the inner orbits. The metal ion with an electron missing from an inner orbit. This is the unstable electronic configuration. An electron, what will happen? The above electron, they will try to stabilize it. From the above electron might be this move from here. When it will move from higher to lower energy, it will emit some photons, and this empty space may be covered from the outer electrons, and electrons when move from higher energy level to the lower energy level, they will emit some radiations, some photons of specific energy. Similarly, the higher electron will fill this one. In this way, the electron will be missing from the outer shell. So electronic configuration is unstable. An electron from an orbital of higher energy drops into the half filled orbital and photon is emitted. So these are photons. And these photons correspond to the electromagnetic radiation of the X-rays. So their frequency, the observed frequency was that falls in the X-rays region. So in this way the X-rays are produced, and they related to the atomic number of the elements. And what are the uses of X-rays or its application? There are a lot of applications. X-rays have different penetrating powers for different types of metal. But X-rays cannot pass through the metal. They can only pass through the plastic or leather. That's why they are used for security purpose to photograph interior of the objects. Like on airports, you are scanned with the help of these X-rays, because they can pass through your bags, leather bags or plastic bags. So they can photograph the inner sides of the object. So this is very important application of the X-ray. X-rays can also be used in medical field for radiography to locate fracture in the bones. Radiography like X-rays, you be quite familiar about the X-rays, like this one. This is the X-ray. You can see the if there is some fracture, these are the bones like ribs. So these X-rays can be used to radiograph the bones. So this has very important use in the biomedical field. In England and in 1913, William Bragg and Lawrence Bragg, they used the X-rays diffraction technique to study the crystal structures of the crystalline substance. Crystalline structures are those in which atoms or ions or particles, they are arranged in three dimensions, x, y and z axis. For example, sodium chloride crystal, diamond crystal. So what is their length and what is the angle? For that purpose X-rays are used, and this study is called crystallography. So this is another important application of the X-rays. Similarly, X-rays can be used to ionize the gases. If they knock out on the they can knock out the electrons of the atoms in the gaseous phase, and gases can be ionized. Students, there are a lot of questions, and some of them are giving you for your practice. How does Moses law help in production of X-rays? So production of X-rays and give its law and give the relation that is showing the X-rays frequency is related to the atomic number. Similarly, what are important applications? You can write all the applications, and also can be asked a particular application like what is its use in biomedical field, how this is used for security purpose, how it can be used for ionization of the gases, for crystallography. So you have to go through and understand it comprehensively, so you can answer all the questions. Students, this was all about the discovery of the X-rays, its production and properties, their types, and also the uses of X-rays. Our next topic will be about the quantum numbers and orbitals.